Here we're going to take a look at the scope of variables. Here we have a very simple program that I declared x 3 times in, and it's legal because each x is in a different scope. This first one up here that sets x equal to 10, that's in global space. Right? So it's a global variable, meaning it can be used anywhere within the program. If we have multiple functions going on, all those functions can use it. And I'll say this now, that a global variable is a bad practice to use them, right? And you should always avoid them. So if you take one of my classes, you should not use them because I don't like them and they're bad practice. The idea behind programming is to protect the data. If this is global, there is no protection to it. It can be modified from anywhere, right? Which becomes very important when we're dealing with classes. This x, which is set to 15, its scope starts at this point where it's declared. Okay, you see here I have a cout statement that's outputting the x. Alright, so this one has scope now between these curly brackets of the main, but starting at this point within main. Then inside the if statement I have the third one, where I set it to 99. Its scope begins at this point between these two curly brackets of the if statement. So from this point forward, x is 99, but we hit the closing curly bracket, this x no longer exists. It loses its scope. It should come back to this one because it's the one that's back, and I have another cout statement. So the scope of a variable depends on where it's declared. Its scope is visibility from the curly brackets that it's between from the point it's declared forward. But we have another one here that's declared inside another set of parentheses. So its scope starts here and ends at the end of the if statement. And this one comes back into scope. And the compiler keeps track of all that. Even though these are all the same variable name, x, the compiler actually gives them different names. So it can keep track of which variable you're currently dealing with in terms of scope. So if we run this program, let's see. Sorry for that flash, not sure what caused that. There's the output of it. First value we see is the 10, which is caused by this first cout statement in main. It's using this global x out here and gives us the 10. We now declared x again to be 15 and did a cout statement right away, and we see the 15. The if statement is true, x is less than y, so it's going to come in here and declare x again at 99 and output it at 99. But if statement ends, this cout statement gives us the 15 back. So even though I reassigned x to be 99, right, once the if statement was done, it was still at 15 once we're out here. So this x is completely independent of this x. If they were the same x in memory, the 15 would be lost. Each one of these is an independent location in memory. So 3 memory locations have a variable called x, and with 3 different values. Again, the compiler gives it a slightly different name so that it does not confuse the 3. Right, but that's a very important concept, that the memory of each of these x is different. They come into scope at different times. This one's global, so it immediately has memory allocated. Once we hit this declaration or this declaring of the x value here at 15, its memory is allocated. Boom, 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 we come through here. Another memory is allocated for x, giving it the value 99. Right, the curly bracket ends the scope of this variable x, so it's actually removed from memory. The only thing left in memory now is this x with the 15 and the x with the 10, right? And there's the x with the 15 that's outputted, right? And in this case, once we hit the closing curly bracket of main, both x's are out of memory now. This one that's declared at 15 and the one that's declared at 10. So again, try to avoid global variables. There is really no reason ever to use them, and it's good practice not to use them.